Hey, everybody. So tonight we are going to be discussing a new open source project from Hopr. Uh, as Drew in the intro said, it has an adorable logo, and it is called Web Retriever. So, like I said, my name is Nick. Uh, I am the VP of product engineering at Hopr. I also run a services company called EITR. And if you want to get a hold of me, my LinkedIn is there. It's probably the best way to get a hold of me. So reach out and say hi if you want to. Okay, so Web Retriever was born out of necessity, and I'm going to talk a little bit about kind of the things that led up to that, and then we'll talk a little bit about what Web Retriever does, and then we'll take some Q&A after a short demo. So start thinking of any questions that you want to ask. I'm happy to answer anything at the end. So if we have machine workloads, so that could be, some applications running within your organization that do stuff. Uh, you're going to have some number of them that need internet access for something, right? Maybe they need to access external APIs, maybe they need to, download stuff. Who knows, right? There's so many use cases that a machine workload could need internet access for. So in scenarios like that, you could have that machine workload having direct access to the internet. Um, so think of I stood up an instance in my AWS account and it has a public IP. It's just going to leverage that to get out to the internet and do whatever it needs to do, right? Um, you could have a NAT gateway, right? So maybe you have a private subnet in your AWS VPC, and those systems need to also get out to the internet. Uh, you would put a NAT gateway in place, and then those systems can get out and do the things that they need to do. Um, and then another possibility might be like running through a proxy. You generally see that with web traffic. So maybe your systems that need to go out to hit an API or pull down web content of some type, they would go through an HTTP proxy and sort of pull that information back through that. So the reason that traditional paths didn't work for us in what we were doing in Hopr with our product Extra and K4C is essentially we use Envoy proxy under the hood to do a lot of the network stuff that we need to do. And that makes it a little bit harder to just get out to the internet whenever we want, right? So say in our case here, we have our diagram at the top where we have our machine workload, say that's running in a container. And then beside it, we have a sidecar container where we have Envoy proxy running, and then a WebAssembly filter that Envoy proxy leverages. That WASM filter is custom code that was written by us at Hopr to do awesome stuff, and it needs arbitrary access to the internet. That is not something that Envoy proxy just does. Um, everything in Envoy proxy land is kind of sandboxed, right? So traffic can come in from your machine workload. It can go out to defined clusters, they call them, but really it's just an external endpoint. So if you needed access to, say, a dozen or 2 dozen different internet locations, each one of those would have to be defined inside of your Envoy proxy configuration in order for you to access them from within the WASM filter. And that is not something that you want to do, right? So if you need access to not large numbers of internet locations from within an Envoy proxy location, it's not tenable to completely rely upon adding the clusters to the configuration every time you need to access a new endpoint. So, faced with that problem, we came up with Web Retriever, which in concept is a really simple application. You know, we like to not overcomplicate things in the development of our projects, but I think that this provides a really cool utility that could probably be broadly useful outside of just our particular use case with Envoy. We developed Web Retriever as that intermediary between machine workloads and the internet. So essentially what we can do is we can define one location that we are going to be reaching out to from our machine workloads. And then that is going to in turn reach out to the internet for us on our behalf and gather the information that we need. So we wrote this application in Python using the plugin-oriented programming framework. That is kind of like a paradigm by which every piece of data and every function is accessible on a central hub. It's really interesting Python framework created by Thomas Hatch, the creator of Salt. Might be worth looking into if you do some Python development, especially if you like to write pluggable code. So we wrote it in Python. Essentially what it does is it provides us an API by which we can request internet information. It also employs an allow and deny rule framework. So we can essentially say, okay, you know, only localhost can hit Web Retriever, right? So that would be helpful in maybe like a sidecar container type of setup, right, where everything shares the same network space. You could specify maybe like a range of IPs or subnet that things could be coming from also, so that you could use it in a scenario where like maybe multiple machine workloads from a private network need to reach out to the internet. We can restrict, you know, what destinations can be accessed. So it's really a flexible rule engine that we put in place. And you know, this is open source. We can expand on it. We can do other cool stuff, and definitely will as the project progresses. Another possibility is like header transformation. So, you know, headers come in from the machine workloads, and we can add headers, remove headers, change the content of them, whatever we'd like, right? Because essentially, it's not so much a pass through, but you know, more a game of you know, pass the potato or hot potato, right? Yeah. The machine workload has its request come in, and then Hopr receives that, turns around and does the request on behalf of the machine workload that's requesting it. And at the bottom there, I have the link to the open source repository. So this is on GitLab. You can go to the Hopr Co organization, and it's right up underneath there. So just to talk through a couple of use cases here. Like I said, this works great for our Envoy proxy use case. We only need to define Web Retriever as the one cluster or external endpoint that we need access to. And then our WASM filter can request the world, right? If we don't restrict the requests in any way with the rule engine, that WASM filter now has access to the entirety of the internet with just configuring a single endpoint instead of having to allow each one by putting in a block of like 30 lines or something like that each time you want to add a cluster. Um, Another possible use case for this um, is kind of like an interesting side effect of changing the architecture that we normally see, right? So on the left, this is how things normally work in AWS or other public cloud providers. You have machine workloads, they're inside of VPCs. They often don't have direct access to the internet through like a public IP, right? It's just not sustainable to roll out an entire architecture with everything having direct access. So oftentimes you see the NAT gateway. The frustrating thing for people running small AWS accounts, like say sandboxes that you just like to play around in, or maybe your home users or something like that, is that NAT gateways end up being a really large cost as compared to your actual workloads. So you could spin up NAT gateway managed by AWS and maybe spin up a bunch of tiny instances to play around with inside AWS. And all of those instances that you spin up sometimes are less expensive than just the NAT gateway. Um, I know that I've done that in the past where I've enabled NAT gateway and I look at the bill, I'm like, oh man, I didn't want to spend that much. But what Web Retriever allows us to do is, because those machine workloads don't need access to the internet, we could, either in small scale or at large scale, through like autoscale groups and load balancers and things like that, we could put a web retriever gateway in between those machine workloads and the internet. And the machine workloads do not need internet access anymore. They just need to be able to talk to web retriever and express what they need in the expected way that web retriever exposes through its API. And I'll show you that in a little bit. And then finally, a really cool use case would be header manipulation. And a couple of like sub use cases would be you could add an authentication header, such as like an API token that you would normally put inside of a header in WebRetriever instead of exposing that secret to potentially many machine workloads. So say you have, a dozen systems and they all need access to this external API, right? You're using like the Google Maps API or something like that. And you have a token that's associated with that. Instead of exposing that secret to all of those workloads, if you just write your application in a way that it just requests that information through Web Retriever, you can have Web Retriever add your API token to any requests that come in for that destination. So it's a really cool use case in that regard, that you only have this single point of access for secrets instead of having to spread that across and worry about that larger footprint for risk. Another possible use case is impersonating a user agent. Essentially, if you're requesting machine workload reaches out to the internet, that remote server can see the user agent of that requesting application, right? So whoever coded that app, maybe they like hard coded something in there. Like Salt, the configuration management platform, when you make HTTP queries, it actually has a user agent that it defaults to that you can tell that it's coming from Salt, right? Maybe you don't want that to happen. You don't want people to know that you're using Salt to make those queries. You don't want that to be publicly accessible information. Or maybe you need to impersonate a user agent because the server changes the output based upon the user agent coming in, right? You need to impersonate a browser or something like that in order to see the page that you're expecting to see. We can manipulate that user agent header when it comes in, and that way the remote server won't know what's actually making the request. And then finally, removing internal or sensitive headers. By default, we aren't going to pass along any of the internal headers. So right away, you immediately will look like you're just coming from the web retriever endpoint, right? You know, you could have 1 or 1,000 machine workloads behind web retriever, and all the remote servers will see is the one system web retriever accessing it, and it won't be able to determine how many systems are behind it, or you know what headers might be included from those remote systems. So some pretty good header use cases there as well. So now we'll switch over to a quick demo. This is, like I said, pretty, I should probably just like type it out at this point. So this is a pretty simple app, right? You know, we're just going to go ahead and run this with a configuration file that we have in place. And I'll show you the contents of that in a second. Right now, we are listening on all interfaces on port 8080, and we are in a public subnet in AWS with a public IP attached to this instance. On the right, we have our system that is in a private subnet. It does have access to this system in the public subnet, but it does not have access to the internet. So we can try on our right side to access an internet system. And you can see that when we try and access that with curl, it just hangs, right? It can't even do DNS resolution at this point, which is what it's attempting and sitting here and hanging, in order to determine that, you know, where this endpoint is. So we'll go ahead and exit out of that. And then instead, if we were to reach out to web retriever, which you know is on this IP in the public subnet, again, we're listening on port 8080. We have our API path where we are reaching out to perform a fetch. We can also perform post calls, but this is just like a normal get. And we're passing parameters here. So we're telling it what URL we want to request and what that content type is. If you don't tell it the content type, it will try to automatically detect that as well. But always better to be explicit. I learned that from Drew Malone. So you can see that we have our return JSON here. This is from web retriever, and it returned an error. It's forbidden by pre-rule 0. So on the left, you can see that we have our you know, web server-esque logs here. And we can see that get request come in on that particular URI, and the parameters are passed along to it. And you see that we pass back a 403, and that the requesting user agent was curl. The reason that we are forbidden right now is because of our configuration. So we can pass in a configuration to our application, And you can see that essentially the way that pop works is you can pass in configurations to each component that's cobbled together to make our app. Pop config is the core pop application that provides the configuration and logging framework. So we are passing in log level info so that we can see the web server log lines that I showed you. We could turn that up to debug, or we could turn it back to the default of warning, and then it would restrict the ability to see anything other than problems with the actual code, not with accessing the system. But below it here, we have the configuration for our web retriever app. And below that, we have our rules key. And this is where the rules are located. We essentially have like a list of dictionaries that we can pass in as rules, and they are read top down. So if we had multiples, the first item would be rule 0, and then the next one would be rule 1, and so forth. But what we've determined here is that we have a rule type of allow, and our rule string is basically a Pythonic representation of the request attributes and what they might be equal to, or what we're looking for, right? So in the documentation for web retriever, it goes into a little bit more detail on how exactly this works. But essentially, the AIO HTTP library has a request object, and that has certain attributes. And one of them is remote, which is basically the remote host that's making the request. And so we are comparing that against this string. And so basically anything from localhost will be allowed. Now, because we're on a different system here on the right, we're not allowed. But what we can do here is we can allow things that are not from localhost. So essentially, it would be the equivalent of a deny rule for anything that's coming from localhost. So if we save this now and run web retriever, if we run our curl request again, we can actually get out and see that the average cat can jump 8 feet in a single bound, nearly 6 times its body length. I mean, who didn't want to know that? So this essentially gives us the ability to put rules in place that our machine workloads are beholden to. Gives us a central point of communication to the internet that's a lot easier to keep track of, right? From like a network firewall rules perspective. It kind of simplifies the whole internet access architecture for machine workloads. I'm not saying that you can use this as like in lieu of a proxy or firewall for your, users who are trying to get out to Google and do their job, right? This is more meant for machine workloads, where we can influence how they request those internet locations. You can see here that we are requesting things using a certain syntax from an API. So we need to have some level of control over the requester. So like internal applications, applications where you can sort of influence what the URLs are that are requested, instead of things where maybe internet locations are hard-coded or baked in to the application. Obviously, we can't change that type of scenario. But anything that's a little bit more configurable and fluid, would be a great use case for web retriever. And so that was me rapid fire running through my whole presentation and demonstration. So at this point, I will answer any questions that anybody might have.
I got one. Can I go?
Absolutely.
Sweet. So, if I'm understanding the numbers of use cases here, could this also be used for like mutual TLS situations where like a machine workload has to auth to a remote endpoint with a cert, but like the developer of that workload doesn't want to have to bother with giving a cert to each of their application instances. So like the say the app on say the inside of Web Retriever could just send a request through, and then Web Retriever just like pops a legitimate cert onto the request and sends it off.
Um, I
Or
guess
maybe
the
that's
answer to that
just
right now is that it could be.
okay.
We don't currently support that in this first iteration. This was just open sourced in in October when we were supposed to have the first talk that was postponed until now, right? Um, so it's only been around for so long. We don't personally have a use case for that, mostly because Hopr's whole shtick is um, being the anti-MTLS. Um,
Okay.
but
Sorry. I was thinking of like, certain customers that I have, they're like
yeah,
MTLS or bust. But yeah, no, I hear you.
yeah. So we could certainly support that in the future potentially. It is open source, so issues and merge requests are welcome. Um, but currently, if you needed that right now, that would be a better application for like putting a Nginx proxy in place in order to tack on that information.
Hmm.
See that we had a comment in chat saying that all demos should involve cat facts. That is definitely something that I agree with.
Hey, Nick, this is Tom McNamara. I have a question. So, from a sizing standpoint, you compared Web Retriever to some of the other, like the NAT gateway and other things, and you mentioned cost. But from a standpoint of the size of that container, is it a smaller than the Envoy proxy container, smaller than the WASM filter? Where does it rank as far as the size and memory and compute power and that sort of thing?
Um, that's a great question. So the answer is it depends, like so many things. So generally, Envoy um, is going to be a larger uh, request on container orchestration systems like Kubernetes um, for resources than WebRetriever would be because Envoy proxy is handling all traffic that's coming in and out, depending on how it's configured. So uh, it would need enough oomph to handle all that. Web retriever only needs to handle as much information as you're requesting from it, right? Like so, um, if you have an application that's like really chatty internally, um, and then only reaches out to the internet, once every 15 minutes or something like that, or once a day or whatever, um, then obviously web retriever can be sized much smaller. Um, as far as size of the actual code base, um, Envoy proxies like big-ish because it's a bigger framework. WASM filters, it depends on who's creating them. Um, and then web retriever's fairly small by itself because a lot of the core of what it does, we're pulling in from external applications. Um, and that's the beauty of pop, right? You can create these applications that leverage existing plugins and not have to worry about um, coding a lot of the boilerplate that you normally have to do, right? So like this is a command line tool. If we run this and pull the help, all of this stuff, I didn't have to worry about doing this, right? Like this is stuff that you would normally have to put in. Oh, I'm going to use Python's argparse and like add in all my different options and stuff like this. Like I literally got all this stuff for free by using Pop, and that's one of the reasons that I use it for rapid prototyping and also just like for Python applications in general, is that I don't have to worry about any of this stuff. Pop and its pop config plugin take care of all this for me. So all of this handling of config files and parsing it in as a dictionary, you know, version string output, logging parameters, all of this is just stuff that's handled for me and I don't have to worry about it. So it's a lot like importing a library, but it's better because I don't actually have to use that library. It just sort of happens because I am using that pop plugin, and it injects its own stuff into my app that I would want to use. So the core code is really just inside of this web retriever directory, and throwing out the PyCache directory. Essentially we have like 1, 2, 3, 4, 5, 6, 7, 8 Python files, and they're all fairly small. Right, like this is probably one of the larger ones, and we're talking about 190 lines, something like that. I don't know if that answered your question, Tom.
Yeah, it did. But I have a follow-up question, if I may. In the demo, you showed doing a fetch or get request, and you mentioned it could also do a post. So could it be used to say grab a log from Envoy? I know Envoy has some observability capabilities. Could you grab logs out of the proxy or the WASM filter and then post that to a destination through Web Retriever?
I suppose you could, but those same metrics are likely exposed to you inside of your WASM filter as well. So depending on what it is exactly that you wanted to pull, you might be able to just gather it programmatically locally inside of your WASM filter.
Thanks.
No problem. Any other questions? All right.
Well, great work.
Yeah.
Great work, Nick.
As I said, you go to Hopr on GitLab and you'll see web retriever. Issues and merge requests are welcome. So come on in and join us in our web retriever adventures. And hey, if we get enough stars in our repo, maybe we'll start making these cute dog t-shirts and giving them out to people. So come give us a star and share the news. We also have a blog post up on the eitr.tech website. If you go to our blogs, there's a little bit of like a quick start in here. Additionally, might not be up yet. No, I don't have read the docs set up yet, but we do have some documentation in place. So if you go into topics, there's some RST files here with like quick start. This is kind of the same thing that's in the blog, more on the rule engine. So this will probably answer a lot more questions on how to use the rule engine for different rule types. Specifically, this transform rule is a little bit more complex, and it adds header, removes user agents and stuff like that. So we can do cool things here. But definitely come check out the documentation. It will be up on the read the docs at some point in the nearish future. But in the meantime, you can just sort of come in and check it out under topics.
Put a lot of thought into this.
Hey, I try. All right.
I mean, I think it's really cool. It's a lot of work. Yeah. Thanks.
Yeah, this is cool.
I'll last round for questions that need answers or any final comments from Nick before we call it for the evening. All right. Thanks again, Nick. This was really cool.
Anytime, man.
Thanks.
Thanks, Nick.